All right, so there are, this is a problem from the homework. Okay, there are 8 chairs on stage, arranged in a strict line parallel to the front of the stage. So there are 8 persons to occupy the 8 chairs, but 2 of these persons cannot sit near to each other. Wait a minute, did I copy it wrong? 2 of the person cannot sit. How many seating arrangements are possible? Oh, okay, maybe the answer, yeah, the answer is wrong. Okay, I guess the problem itself should be, let's change the problem and then the answer is that. So 2 of these people must sit together next to each other. Okay, yeah, let me change this first. Must sit next to each other. Okay, let's do this part first. Okay. 2 of those 2 persons must sit next to each other. How many sitting? Yeah, let's do this first. Okay. So if you can do this problem, okay, then the opposite way, if those 2 persons must sit next to each other, okay. So if you can't do those arrangements first, then you do the subtraction. You can get the arrangements 2 of these 2 persons cannot sit next to, do not sit next to each other. Okay. So let's do this problem first. Okay. So 2 of these persons must sit next to each other. How many seating arrangements are possible? So you have 8 seats. 1, 2, 3, 4, 5, 6, 7, 8. So you're going to make arrangements. So those 2 persons must sit next to each other. So you have to select a pair of chairs next to each other first and put those 2 people there. Okay? So either this or that or this, right? How many pairs of seats you're going to get? 7. So 7 choices, 7 pairs. That's the first step. You choose a pair of the seats, okay, for those 2 people. So 7. So 7 choices. Then second step is to put those 2 people to those 2 seats. There are only 2 people here, so you choose it's 2, right? 2 choices. You can switch them, right? Then for the remaining 8 seats, 6 seats, you can randomly put the 6 people, remaining 6 people. So there'll be 6 factorial many. Okay. All right. So this is the answer to the above question. Now, if you want to, if 2 of these people cannot sit together, okay, this is for the answer, right? So if 2 of these 2 persons cannot sit together, then you just total number of the possible arrangements minus those arrangements. Do the subtraction. The total number of seats, as total number of arrangements without any restriction is going to be 8 factorial, right? Then you minus this. Then the remaining will be the answer, yeah, 30,240. Okay, you can you can multiply this out. It's going to be 30,240. Yeah, I should all right, so this is they use subtraction. You cannot solve the problem directly because how do you make arrangement? What is the first step we can do? Guarantee as two persons do not sit next to each other. It's hard. Okay, it's so complicated. So what they do is much easier to find out arrangements so that the two sit together. So we already did a similar problem before. Okay, similar problem before. Okay, let's do a similar problem. We have let's see, we have 6 people. Yeah, will be sit in a row. Okay, which you divide into 2 groups, left and the right. Okay. So if how many, the question is, if 2 of those people must sit next to on the same side, how many sitting arrangements are possible? Okay. If 2 of them must sit on the same side, not next to each other. Okay, how many sitting arrangements are possible? Okay. It's not necessary to sit next to each other, right? And if I change the problem, say must sit next to each other, then the answer will be slightly different, because this whole row is divided into 2. Okay, and one is on the left, the other one is on the right. Across this middle line, we don't say they are next to each other. Okay. All right. 280? 288. Brian Zhang got 288. Any different answers? $48. Okay, so we, those 2 persons, we call it A and B, right? So in order to let A and B sit on the same side, what is the best way to do? Step 1, you let A to select any of the seat. Okay, you let A to select any of the seat. So it could be here, could be there, doesn't matter. So how many seats A can select? 6. Then that's the first step. The second step is you have to let the B to select the seat. But the B only have 2 choices, because if A sit on the left-hand side, the B has to go to the left-hand side. Then when he gets there, it's just only 2 seats he can choose. It's only 2. Okay? Then there are 4 people left, 4 seats left. And you can, just randomly arrange them. So it's a 4 factorial. So that is the answer. If you multiply them out, then you get 288, right? 288. Okay? So that's 3 steps. Right? 3 steps. 3 major steps. Right? So now we are going to move on to the next topic. Okay, so so this is about counting line segments, rectangles, or triangles. Those are geometric counting problems. Okay, so the first example is I have two cities, A and B, and between them I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is a city A, city B, and there are 7 train stations, including the stations at city A and city B. How many different tickets should be prepared? This is a train station. Okay, there are 7 train stations. Yep. Okay, so here the tickets are printed in the following way. As long as you have 2 city names, that's a ticket between the 2 cities. Doesn't matter forward or backward. Okay, usually you have to. There's a direction. This is from city, X and Y. Then you have to just type X and Y. So as long as you have a 2 city name, that's the same ticket. It can go back forward. Doesn't matter. It's a price, the same price. Okay. The basically is how many different prices you can have, right? Yeah. So you can go here, from here, you can go from here to here. Okay, so you want to print how many different type of tickets. Okay, and there's assumption if the 2 cities, between 2 cities, just as long as there's 2 city names on the 1 ticket, then you can back forward, doesn't matter. Okay. Yes. Huh? 42. We already said that the ticket has no orientation. Okay. As long as there's 2 cities on the ticket, then doesn't matter. You can use that to go back forward. It's only 21. Yes. Yeah. So how to do that? This is there's a formula we call the you have 7 points here. 7 points. Just needed to see like how many pairs of points you're gonna get. Okay. So the number of pairs of points selected from selected from the group of 7 points is going to be, you have 7 different points here, right? 7 different cities. The number of the pairs of cities selected from the group of 7 points, we do have a formula, but I'm going to show you how to get this formula in general. So it's going to be 7 factorial, and then 2 factorial, 7 minus 2, which is going to be 5 factorial. After you compute it, it's 21. A factorial means 7 factorial is 1 times 2 times 3 times 7, right? So let's, if you understand this, you translate the problem to the following problem to count the number of the pairs of points selected from the group of 7 points. Now, there's a standard formula there, okay? There's a standard formula there, and you can use, but if you don't want to use that formula, how do you solve the problem? So how do you solve it? If there are not many points there, then it's easy to do that. 1, 2, 3, 4, 5. And then this is where we calculate 1 pair, just directly count them, okay? If you direct count them, that's the first run, okay? So this is going to be 6 pairs. Then from here to here, you get 5 pairs. And then from here to here to here, you get 4 pairs, okay? And then 3 pairs, then 2 pairs, then plus 1. So add them together, you will get 6 times 7 divided by 2. It still gets 21. Okay? It's different way, but only when you have a very small number of points you can do that using the problem. Okay? But then otherwise you can use a formula. So here's a standard formula. Okay, the number of k the number of groups of k members selected from the group of n members is going to be n factorial k factorial of n minus k factorial. Okay, so this is how do we get this number? Okay, let me show you the proof. Okay, so you have a group of P1, P2, P3, right? Pn. You want to select them, and you get key members selected, right? How do you do that? So you choose one by one from here to right, move to here. First of all, you put them in a row, right? Then you needed to select key members. So the first one, you have n choices because there are n numbers in the back, right? In the group, you select one. How many choices the first step? N choices. Second one, you have n minus 1 choices because 1 is already selected. Then you want to select the key member, so it's n minus k minus 1. So this is a many choices for the case member, right? So if you put them in a row, and if we count the order, then the product of these numbers, okay, is going to be the number of members in the order, okay? But if we do not count the order, we can permutate them. Then you have to divide by k factorial. So this is the number of groups of key members. When we say group, we don't count the order. So you have to divide by k factorial because every time we permutate them, you don't create a new group. But if you put it in a row, they are all different. All right, so that's why at the very beginning you have the number of the product of those numbers, but now you have to divide by k factorial. But if you rewrite this again, this is going to be written as k factorial and the k and the n minus k factorial. Okay, so that is how do we get this formula. So we can use that formula to solve problems. All right, our next problem is a 6 by 8 rectangles. How many rectangles we are going to get? Okay, so 6 by 8. 1, 2, 3, 4, 5. So you have to say 1, 2, 3, 4, 5, 6. 7 and 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. All right. So how many rectangles are there? A rectangle means, let me show you. For example, this is a rectangle we're talking about. Okay. So how many rectangles different size? How do we count them? How do you count them? Okay, you have to know that you have to change the problem a little bit. To determine a rectangle, you needed to determine 2 horizontal lines. Yeah, you have to need to determine 2 horizontal lines, right? And you also need to determine 2 vertical lines. All right? Right? So 2 horizontal lines, 2 vertical lines uniquely determine a rectangle. So 2 vertical lines, you just need to determine a pair of vertical lines. How many vertical lines there? 1, 2, 3, 4. Right? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. There are 7 vertical lines. How many pairs of vertical lines you're going to get? Right? It's going to be the number of pairs of vertical lines is going to be 7 divided by 2 divided by 5 factorial is 21. Okay? That's a 21. Then the same idea, how many horizontal lines there? Total is 9. 9 horizontal lines. And you are going to select a pairs of horizontal lines. That's the second step. So number of pairs of horizontal lines is going to be, because you have a 9 horizontal lines there, so multiply by 9 factorial. I already show you the formula, right? And 2 factorial, and the 9 minus 2, which is 7 factorial. So it will be 8 times 9 divided by 2, 36. Okay. Now, how do I quickly cancel that? Because 9 factorial can be always written 7 factorial times 8 times 9. So 7 factorial and 7 factorial canceled out. So in order to select the rectangle, it involves 2 steps. Step 1, select a pair of vertical lines, which is, there are 21 pairs of vertical lines, 21 choices. Step 2, select a pair of horizontal lines. There are 36 choices. Then you have to, 2 steps are independent. So the total number of choices, right? Number of ways to select the rectangle is going to be 21 times 36. Yeah, it's going to be 21 times 36. Yeah. Yeah, it's going to be 756. Okay. For the same problem, my next question is, how many squares there? Aha. So the number of squares should be smaller. How many squares are there? All right? So it's the same for the same picture, okay? How many squares there? Yeah, the square could be different size, 1 by 1, 2 by 2, 3 by 3, 4 by 4. The largest square is 6 by 6. Okay? The largest square is 6 by 6. One, 2, 3, 4, 5, 6. 7, 8. All right, so how many square there? This is still 6 by 8, okay? How many square there? So you have to count in different ways. This time, you count in the following way. You count the squares of the number of the square, 1 by 1 squares, 2 by 2 squares, 3 by 3 squares, okay? And so on. So the largest square you're going to get is 6 by 6. Okay, so this is the largest square you can get from the picture. So you just need to count. My hint is count the number of squares of same size Okay? You cannot use you can still use a pair of a horizontal line, pair of the vertical line, but the pair of the vertical line and pair of horizontal line, that should have a, two lines, the distance between two lines, that should be the same. Two, or, if it's 2 by 2 square, then, right? So the number of unit square will be clearly 6 times 8. But how can I find out the number of 2 by 2 squares? Okay. The number of 2 by 2 squares, you can do like this. The pair of the vertical lines must be, the distance must be 2. So you can choose this pair, 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 right? So 1, 2, 3, 4, 5. There's only have 5 pairs you can choose. And then here I have 1 pair, 2 pair, 3 pair, 4 pair, 5 pair, 6 pair, 7 pair, 7. Okay? So there are only 5 times 7, 2 by 2 squares. And similarly, and you will see that it's going to be 4 by 6. Okay, 5 by, 3 by 5. And then 2 by 6. Then 1 by, 2 by 4. Okay, always confused. 1 by 3. Right? Okay, so 1 by 3. Okay. So all you have to do is add them together. So it's not easy to add them together. 5 times plus 8, 7 plus 5, 4 by 6, 3 by 5, 2 by 4, plus 1 times 3. So you get this many squares. Okay, you get this many squares. We're not able to simplify directly. Just use you can use a calculator to figure it out. Okay. So that means we have to divide the squares into different group of different size. Okay, different groups of same size. And then you count the squares of same size. Okay, and this idea will be used to solve the following problem. The dots on the square grid are equally spaced by 1 unit horizontally and vertically. Okay, let me draw the picture first. Okay, so the distance, they are, horizontal distance, vertical distance between 2 dots will be 1. How many squares have all their vertices among the dots of the 4 by 4 grid, such that all their sides have either integer length or can be non-integer length? Okay. Yeah. How many squares? Right? So could be integer length, could be non-integer length. So let me show you the one was not a non-integer length. I think this one. This is a square, okay? And the edge length is going to be square root 2, square root 2. So this is also because the square is not horizontal. It's not necessarily be in the perfect position square. So it could be like that, okay? Another possible one is so there. What do you got? Are you sure you got 18? It what Chen says 18. Huh? It should be 18. Okay. So we needed to first of all count those horizontally, horizontal squares, right? Those who are horizontal squares. Then you know that how many squares you're going to get, right? So different size. Okay. So this is let's count this. So those are it's one by one in this position, right? How many of them? Okay, you have a 4 by 4. No, 3 by 3. It's 1, 2, 3. Okay, 3. Okay, so for example, yeah, you have like this. You have a 3, right? And so 3 by 3. Then you look at those 2 by 2 one, that's be 2 square, okay? Then the largest one is just 3 by 3. Yes. So total will be, and then then the largest one is going to be 1, 2, 3, 4, 1, 2, 3, 4, right? So it's just only 1 square. So total is 1 square plus 2 square plus 3 square. But those are only for the horizontal one. You need you have to count the one with the edge length square root 2. And square root 2, square root 2, square root 2. Okay? So how many of them? I think there are 4. Right? It's easy, just move this one downward 1, right? Then you move to the left, another right. So total there'll be 4. So there'll be 4. Now, is there any other other squares? I think you can find another one. Okay, let's try this. All right, and you rotate. So there's 2 there. Okay, so there are 2 different. So total will be 1 square plus 2 square plus 3 square plus 4 plus 2 is 20. So I hope you can do the next problem not missing anything. Right? The question is, how many isosceles triangles can be created using the vertices? Okay, so we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, the distance between those 2 points, horizontal 2 points, the vertical 2 points is 1. Okay. Okay, so let me draw the picture. The possible isosceles triangle is like this. This is one of the isosceles triangle. Okay. So you have to figure out what are the possible size of the isosceles triangle you're going to get. Then you count one by one. Okay. So the first type will be like this. 1 by 1, the square root 2. This is a right isosceles triangle. How many of them? Okay. So this is one type of isosceles triangle. There are 10 or but this could be also in that form. No. So actually it's 20. 4 times 5 is going to be 20. Okay. Then those two triangles in a different location, we call them different triangles, right? So you can have this type. You can also have this type, right? So that's why you can move to the left, to the right, and count that's how many of them, right? So you figure out this. Then you try the next one, right? The next one, next type will be this. Here's 2. That's a square root 2 and the square root 2. Right? This is also an isosceles triangle. But when you move to, and then you can turn upside down, right? Always don't forget. It's 2 square root 2 square root 2. So you have 1, 2, 3, 4. 4 times 4 times 2, you get 8. Okay? Yeah, you can move the first type of isosceles triangle from left to the right. You find out you have a one pair, right? You have another pair and another pair, and so total have 4 pairs. Okay. Any other type of yeah, you can also have the one longer here, right? It's a square root of 5. And this will be 1, 2, 3, 4. Okay. So you can get a 2 like that, then you multiply by 2 because then It's also upside down. So 2 by 2, that'll be 4. Okay, you have 4 such triangles. So total 6 is now, yeah, that's it. You don't have any others. So the total will be 20 plus 8 plus 4, and that would be 32. So Brian, you got 32, good. 32. So it's not easy to count it, right? You have to, first of all, you have to figure out all the possible size. For each fixed size, you count those figures. So the next topic is we want to count the lines and the regions. Okay, we try to find the formula. So the line in the plane, you have many lines, right, in the plane. So the L means the number of the lines, and the P means the number of intersection points. Is there any relationship between P and L? All right. So first of all, you have 3 lines. The maximum number. Okay. The maximum number of intersection points. So with 3 lines, you get 3 intersection points. 2 lines only get 1, right? Let's look at the picture. 2 lines, you have 1. When it's 2, right? When L equals 2, P is going to be 1. And here, when L equals 3, P is going to be 3. Okay, we're trying to see any possible patterns. Okay. Well, how can I draw the other one? Right? It's complicated, right? So when L equals 4, P is going to be 1, 2, 3, 4, 5, 6. So L is increased by 1, but P is increased much fast. Okay. So you have to find a sequence of numbers, then you figured out the general formula. Okay. Maybe you already know the formula, right? But my suggestion is to, yeah. So the formula I have here is, it's hard to draw 5 lines. Yeah, it's really hard to draw 5 lines. Try this. Okay, 1, 2, 3, 4. Then, whoa. 5 lines, right? Like this. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when L equals 5, P is already going to be 10, and so on. So you have a P equals 3, 4. We maybe can find a formula. Okay, going like that. Do some experiment, right? So you have a 1, 3, 6, 10, right? Then do one more maybe, right? So actually, the formula, suppose you don't know the formula, then this is where how do we figure out the formula, okay? So you take the difference, is 2, 3 minus 1 is going to 2. We're trying to find the pattern and find the general formula. 6 minus 3 is 3. 10 minus 6 is going to be 4. So it looks like it increased by 1. Every time it's increased by 1. Okay, so more general, I have a A2 minus A1. I'm going to use a P, okay, because P2 minus depends on, yeah, actually it's P2, it's actually P3. The 3 means P is corresponding 3 lines. P3 minus P2 is going to be 2. 2, okay? So how do we find the P4 minus P3 equals 3, right? P5 minus P4 equals 4. And finally, you have a PL minus PL minus 1. So question is, what is the number? That's the L minus 1, I'm pretty sure, okay? So add them together. All the terms in the middle will be canceled out. All the terms in the middle will be canceled out, right? So you will get PL minus P2 equals 2 plus 3 plus 4 all the way to L minus 1, okay? There's 1 is missing here, right? P2 is what? P2 is 1. P2 is already equal to 1, right? P2 because 2 lines only intersection point is 1. So the answer would be L minus 1 times L divided by 2. That's why, how do we get the formula? All right, so if we have a line, L lines, and the maximum number of intersection points will be given by this formula, okay? How do you get this formula? You know, it's hard to guess at the very beginning. So you get a sequence of a few numbers, then you figure out the pattern, then you get the general formula, okay? So this is how, I'm not going to, this is how do we get this? Now another question is, how many, if you're given P points, okay? And how many lines can be determined by those P points? The maximum number of lines, okay? So that's the opposite, right? You get points, and you, given, so P point determine L equals P times P minus 1 divided by 2 lines, okay? For example, you have 2 points. There is only 1 line passing through the P point. When P equals when P equals 2, L is going to be 1. So 2 times 2 minus 1 divided by 2 is 1. So you have 3 points. 3 points determine 3 lines. Three lines, okay? And the 4 points have 1 line, another line, another line, another line, and this line, and those lines, right? So how many lines when P equals 4? It's going to be 4 times 3 divided by 2, 6 lines. Let's count. 1, 2, 3. Okay. 6 lines or not? Yeah. 4 points determine 6 lines. Okay. So let's say 1, 2, 3, 4. I think 1, 2, 3, 4, 5, 6. Yes. Okay. So that's 6 lines. All right. So those are the formulas. You know, I did not want to derive that for you. It's similar to the above argument. Okay. The third formula I want to talk about is airlines determine how many regions in the plane. Airlines determine at most R, which is going to be 1 plus L times L minus 1 there are 2 regions. Okay, for example, you have one lines. How many regions again? 1 and 2. 1 and 2. Okay, 2 regions. When L equals 1 and I is going to be 2. 2 regions. Right? And you have 2 lines. You have 1, 2, 3, 4 regions. When L equals 2, I equals 4 regions. And then we get the above formula. Okay. Then if you have 3 lines, how many regions you're going to get? 1, 2, 3, 4, 5, 6, 7. 7. How do I get 7? If I use a formula, it's going to be 1 plus 3 times 2 divided by 2, which is 7. Okay. Why we do need that? Because in some applications, sometimes we want to figure out how the number of regions increase as the lines increases. Okay, actually, the number of regions is a quadratic function of the number of the lines. Okay, it's not a linear. It's increased much faster. It's not proportional to the number of the lines. Okay. All right. So let's take a look at the following problem. Now we have a bunch of formulas, right? Okay. Here's a question. What is maximum number of overlapping regions created by 71 distinct lines? Okay, so here you have to use a formula. So you are given the number of the lines. L is going to be 71, right? And you cannot draw 71 lines and count them. It's impossible. Now you derive the general formula, right? I is going to be 1 plus L times L minus 1 divided by 2. L plus 1, so not L minus 1. Hold on. Yeah, this is the formula. Let's go back to here. 1, 2, 3, 4, 6, 7. Yeah, so that should be 4 here. Yep. Yeah, the formula I got here is plus. Based on my observation, it's plus, not minus. Okay, I correct this. So now it is going to be 1 plus 71 times 72 divided by 2. And if you multiply this out, that's a huge number. So using 71 lines, you can divide the whole plane into 2,257 different regions. Okay. Another problem is how many lines? No 3 of them are collinear intersect at 78 points. Okay, so you know that those are the points. 78 is the intersection points. You want to figure out how many lines there. Okay, the condition is no 3 of which are collinear. Okay, no 3 of them are on the same line. So you have to recall the formula the number of the intersection points is determined by the number of the line by this formula. Okay, we already derived this formula. You know, you have a number of the point is going to be number of the intersection points is going to be determined by the number of the line. So we solve the inverse problem. We get 78. So when you get an equation like that, what is the best way to solve it? Of course, use a quadratic equation. You can use a quadratic formula, but that takes too much time. I think the quickest way you can solve is you try to express as a product to construct the numbers. Okay, when you factor this, okay, you factor this, you will get, you know, first of all, I think it's divisible by 3. Let's look at the formula. Okay, so 71, right? 78, it's divisible by 2 and divided by 3. So divided by 6, it's a 13. 6, 2, right? First of all, why use a 6 to divide it? Because I know it's divisible by 2, 78. I also know that it's divisible by by 3 because the sum of the 2 digits is 15. So why not I just divide by 6? Then I get 13. So that's 12, right? So that's going to be 13 times 12, and clearly L is going to be 13. So that is the best way to solve the equation in this case. All right, the last topic I want to talk about the tiling problem, okay? 15-foot by 45-foot rectangular floor is completely tiled with 1 foot by 1 foot square tiles. So this is a 15 feet. Here's 45 feet, okay? As those is it's going to be tiled with 1 by 1 square tiles. Okay, so 1 foot by 1 foot. So if you never done this construction remodeling, suppose you have this size of a room, you want to put the tiles right into 2 rows to buy. Okay, then you know how many pieces you're going to buy. No question about that. Right? What I'm going to do is, I 2 opposite corners of the floor is going to connect by diagonal line. Okay, so in this case, this diagonal passes through the interior of how many? Exactly how many tiles? Right. Well, it's harder to draw them, you on the piece of paper, right? You cannot draw so many different square there and it draws a line. If you can do that, then of course you can count them directly, right? But sometimes you don't have these tools to do that, right? So what is the best way to do? I think you can reduce the problem to think about 15 and 45. 15 and 45, 45 is going to be 15 times 3, right? 45 is 3 times 15, okay? So you can, yeah, it's not a perfect graph. And let me redraw it, okay? So I have on my picture here, I got, yeah, this is good. Yeah, this is a, you see, this is a 15 times 3, okay? Then you draw the line. So what I'm gonna do is, I can put the 3 tiles group together. So we're going to use, this is a 15, okay, 15, 15. Okay, so 3 tiles together, and you can using 1 by 3 tiles to fill the whole area, right? So what you can do is, you just needed to using this 1 by 3 tiles, okay? Using 1 by 3 tiles to fill the space, okay? So if you do like this, then you just need to count how many 1 by 3 tiles along the diagonal, okay? So you will see that you have a 3 here, so 15, right? 15 times 3, so it's have 5. 5 3s here, right? Yeah. So you can divide this problem into, you can zoom in, you can just need to consider this block only. Yeah. So those three square, they are identical, right? This is they're identical. Those 3 rectangles, they're identical. So as long as you can count the tiles in one rectangle, small rectangle, you can solve the problem. Okay? And then it's much easier to count right now because it's going to be one side is a 5, other side is 15. 5, 15. Right? Yeah, let's enlarge this again. Okay, so this side is a 5 and this side is a 15. Okay, but you can use those 1 by 3, 1 by 3, 1 by 3. So you can see that how many you need, right? 1 by 3. Each time 15 divided by 5 is 15 divided by 3 is you have 5 1 by 3s. Okay, 5 1 by 3s. So actually, it's easy to count right now. This is I just need it's a 1 by 3. Okay, for each 1 by 3 is a diagonal past 3 tiles, right? So total actually 15 tiles along the diagonal. 15 tiles along the diagonal. Okay. Yeah. So there are 15 tiles along the diagonal, and my answer is 15 times 3. It's still 45. 45 times. Yeah. Okay. This is easy. But the next one, I wanted to talk about one more. Okay. The next problem is this is going to be the floor. It's a square. Okay. the diagonals loom a draw. Okay, so here's a question. The size is not fixed. The floor of a square okay. And we know that the two diagonal intersect a total of 20 tiles. How many tiles on the floor? That's the inverse problem. A total of 20 tiles. Right? How many tiles are on the floor? Okay. Then the number of the tiles on the floor is n squares, all right? If it's n by n. Okay, so total n squares. The question is, what is the n? What is n? Gives you 20 tiles. Okay, so there be n could be even, can be odd. Then you figure it out the number of tiles. Okay. So you have to decide whether n is going to be even or n is going to be odd. Okay, so let's look at the n. Right, that's two possible cases. If n is odd, okay. If n is odd, okay. How the picture does it look like? If n is odd, let's look at the three case, 3 by 3. Okay, 3 by 3. Then it looks like that, right? If n is odd. So how do you count them? How many? There's one overlap, right? First of all, the one diagonal intersects n tiles. Another diagonal also intersects n tiles. Okay, but there's one overlap in the middle, so it's -1. So this is a number of tiles on the diagonal. Okay, and this is the other number. It's impossible. This is 2n minus 1. Impossible. Okay, because this cannot be 20. Then you look at n equals even. Then you look at the just as the few. You know, you can look at the 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, right? Then you look at this case. Okay, let's count how many when n is even. When n is even, each diagonal has n tiles, right? But they're not overlap. Okay, so that's why it's going to be n by n. You don't need to subtract 1. It's 2n. So the two diagonals intersect the 2n tiles, and n tiles is going to be 20, right? So n must be equal to 10. Then the number of tiles on the floor is going to be n squared, which is 10 squared, and that is going to be 100. Right? So you have to look at two cases and find the general formula for the number of the tiles on the diagonal. Okay, and for the squares, it's much easier to handle. So you can only two cases. One is like the second picture, right? The first one, yeah, when n is odd, and you can see that that's overlap. You know, this is a right. This is the overlap. So it's harder to draw it. It's overlap yellow and yeah, it's harder to draw it. So they're different color. That's the reason I have to subtract n plus n, right? The number of the tiles on the diagonal. So one is even, other one is odd numbers. This even number is possible, and 2n is going 20, then n is going to be 10. Okay, this is I think I discussed almost all the problems. What I want to say that I trust you do the homework. Okay, I hope your parents monitor you. So it's very important to make a progress, not just sit to listen here. You have to finish. You have to do your best to finish all the homework when you get home. Okay. So my suggestion is you read my notes first. Okay. Look at all the examples you understand. Then you start the homework. Don't look at the answer key. You should show the details on the separate paper. You don't need to copy the problem. Just write down the number and show the details. Then you solve the problem. You try to solve all the problems, and at the end you check those check the answers. If the answer doesn't match, and you redo it. Okay, there are some problems you probably needed to spend more than 10 minutes. Okay, but you should try. Don't give up within like 1 minute. You can solve. No clue. You look at the examples, then you go back to the problem. Okay, some of your parents probably can help it, but not all the parents can help you solve this problem. In that case, you can ask your mom and daddy sending me a message. Hey, you know, you cannot do those two problems. We should have time to discuss the homework problems at the beginning of the class. Okay, so then you can make a progress, and I hope after this course you are super great. You know, you study all the required mathematics in the middle school.